read the directions, pause the video so you can get your materials together. These are the notes 13-1, solving systems of quadratic and linear equations. The date that we are putting on is for tomorrow, so it's 4/11. A quadratic and linear system is a quadratic equation and linear equation where an ordered pair makes both equations true. So question number 1 says to graph y equals x squared minus 6x plus 6, which we will do a table of values for, and y equals x minus 4, which we will find the slope and the y-intercept and graph in that way. The point at which these two equations cross each other or intersect is the point or the solution point, and we will write it as an ordered pair of x comma y. So the values for x squared minus 6x plus 6 that I want to use, I can start with -2, -1, 0, 1, and 2, but I'll find that I need to go higher in values. So I'm going to start with 0 and count up 1, 2, 3, 4, 5, and 6. So 0 squared minus 6 times 0 plus 6 is 6. Substituting the 1, I get 1 squared minus 6 times 1 plus 6 is 1. 2 squared minus 6 times 2 plus 6 is -2. 3 squared minus 6 times 3 plus 6 gives me -3. And this is my vertex right here because now it's going to take a turn. And 4 squared minus 6x plus 6 will give me -2. 5 squared minus 6 times 5 plus 6 will give me +1. And 6 squared minus 6 times 6 plus 6 will give me +6. And if I go ahead and plot these points, you'll see a nice U-shaped parabola. For y equals x minus 4 is a linear equation, so it's a straight line. The slope is 1/1, and the y-intercept is -4. So starting at -4, I'm going to count up 1/1, up 1/1. On the third point that I plot, you'll see that you're intersecting the parabola at 2, -2. And so that is the solution to this quadratic and linear equation. I also continue my line across the graph, and you'll see that they intersect again over here. So let me mark them with 2 different colors. I have 2, -2, and then I have this point, which was 5, 1. 5, 1 is also a solution. So in this set of linear and quadratic, I actually have 2 solutions instead of 1. 2, -2, and 5, 1. For question number 2, you're going to do the same exact thing, making a table of values for x squared plus 4x plus 1. And the linear equation, y equals 2x plus 1, has a slope of 2 and a y-intercept of 1. So the values that I want to use for x squared plus 4x plus 1 are actually -5, -4, -3, -2, -1, 0, and 1. So -5 squared plus 4 times -5 plus 1 will give me a positive 6. -4 squared plus 4 times -4 plus 1 will give me a positive 1. -3 squared plus 4 times -3 plus 1 is -2. And this is my turning point, or my vertex, right here at -2, -3. And then I continue on, getting -2, 1, and 6. I'll show you tomorrow on the graphing calculator how you can plug in the quadratic and the linear and see the table of values and see where they have the same values and the same points of intersection. So if I plot these ordered pairs at -5, positive 6, -4, positive 1, -3, -2, -2, -3, and then we turn, I get a U-shaped parabola. That looks like this. And now I'm going to plot my linear equation starting at positive 1. And right away I see that that point, 0, 1, is also a quadratic's point, and so that's one of the points of intersection. So from there, I'm going to go up 2 over 1, up 2 over 1, and it looks like if I continue to go down 2 over 1, you'll see that I have another point of intersection here at -2, -3. This is why I want to be very accurate with where I place my points, and then check on the graphing calculator tomorrow in class when I show you exactly how to use it, because I want to make sure that I have the correct points of intersection. And so I have two solutions, 0, 1, and -2, -3. For the last example, example number 3, I think you should pause the video and try to do the graphing portion on your own and see if you get a solution. I do have to rearrange the 2x minus y equals 2. So what I'm going to do is I'm going to add y to both sides. And then I'm going to subtract 2 from both sides. That kind of saves me from having to deal with the negative y. So I have 2x minus 2. So I know my slope is 2 over 1, and my y-intercept is -2. So for my y equals x squared plus x minus 4, I'm again going to make a table of values for my x and y columns. And I'm going to use -3, -2, -1, 0, 1, 2, and 3. And so if I plug in -3 squared plus a -3 minus 4 will give me a positive 2. -2 squared plus a -2 minus 4 will give me a -2. -1 squared plus a -1 minus 4 will give me a -4 or -4. 0 squared plus 0 minus 4 will give me a -4. So the turning point, the vertex, is somewhere in between 0 and -1. We have 1 squared plus 1 minus 4 is -2. And then we have 2 squared plus 2 minus 4 gives me a positive 2. And then if I go one further to do the 3 squared plus 3 minus 4, I get 8. So if I plot all of these points, and I graph my parabola, it dips just below negative 4 and comes back up. So I don't actually have a vertex. It would be a decimal or a fraction. Now if I graph my line, I start at negative 2, and I'm going up 2 and over 1. I hit my first point right here at 2, 2, my first point of intersection. And my second point would then be at negative 1, negative 4. And I can plot my line, or draw my line, and the graph looks like that. So my solutions are negative 1, negative 4, and 2, 2.